Hello everybody. I wanted to do some just genetics refreshers for you while we're away on spring break, and somebody had told me that they weren't quite sure that they understood about blood typing. So I know everybody completed this activity in class, and I thought we would just go back over this again. You'll see it's very similar to your uh, notes that you have. Because I cannot run Notebook on my laptop at home, I had to use a different resource. So same information, but just a little bit different appearance with this. So let's take a look at this. The first thing, and you know me, when I have to write with this, it's not the best outcome, but we're going to try this. So let's see how we can make this work. Okay, so we're just going to start out. I've drawn a letter I here because in blood typing, what we do is we use the letter I as our indicator of blood type. And then what scientist or geneticist will do is they will attach the allele for blood type in the superscript position of this I. And this whole thing right here, which would be the genotype, is going to be considered as one letter. So what I'm saying here is when I have this I with the A attached to it, that this is A type blood, and that's what that tells me. So for an A type blood individual, I can have two dominant, well, they're codominant, but two capital A alleles attached to the I, and this individual would be considered homozygous for A-type blood. Now, A-type blood people can also be carriers of the O allele because O is recessive. So if we have the A allele, like we see here, a carrier is going to have that recessive O allele for that. So this would be considered heterozygous for blood type. So the same thing would be true for B type blood. We would take this I genotype, but now in our superscript position, we're going to attach a B. And B's are a little bit hard for me to make, as you can see. So an individual that would be homozygous for B-type blood would have two B alleles on their I genotype. So this would be homozygous. They could only pass on that B trait. They could also be carriers for the O allele. So if they were carriers for the O allele, we would have the B genotype on that I, and then we would have the recessive O allele in its place. Okay, does that make sense to everybody? I hope so. For O-type blood, we're going to have two recessive I alleles. That's the only way you can have O-type blood. And this won't make a little dot for me. I cannot dot my I. Oh, I hate when it does that. Let's see if I can get this back. And it disappeared. As always, it's a challenge. I told you it's a challenge with. Okay, so if we have the O combination, as I was trying to say, it's not liking me today. Let's see if I can get out of this and try it again. One more time, three's a charm. Okay, so our if we have an O allele, this would be homozygous for O-type blood. So that's the only way a baby is going to have O-type blood. Now, blood, as we mentioned, is codominant. A-type blood is not dominant over B-type blood, but both A and B are dominant to O. So the codominant combination, we're going to have two I's to represent our blood type. One I is going to have an A linked to it, and the other I is going to have a B linked to it. Okay, this is codominant, and this individual would have AB type blood. Okay, does that make sense to everybody? I hope so. So let's take a look with that information under our belts. Let's take a look at this problem. Okay, so in this problem, and let's see, I'm going to switch to blue. And can I make my lines a little bit thinner? No, I can't. All right. So in this problem, we have three babies that were mixed up at a hospital, and we know the types of blood types of the parents, and we know the blood types of the babies. So what I'm going to do, I'm just going to look at parents 1 right now, and I'm going to move parents 1 here, and I'm just going to put a number 1 here to represent parents 1. They have A and B blood. You know what? Let me backtrack. Sorry about that. Let's look at what we know, okay? So I'm going to take parents 3. Sorry. We're going to look at parents 3 because we know a lot about parents 3. Parents 3 have A, B, and O blood type. So we know that parents 3, in order to have AB blood type, that genotypically the AB parent can only look like this. And the O parent can only look like this. I might not be able to dot my I's. Yeah, I'm not going to dot my I's, but you know that they're dotted, okay? So when we know this, we could actually do this Punnett square, and we could separate the AB parent here. Come on. The B parent there, the I and the I. And when we bring these together, the only type of children or blood types that they could have would be A type blood with the carrier of O, and B type blood with the carrier of O. And I think you can see that this would be the same combination. It would be A type blood with the carrier O, and this would be the B type blood, the carrier of O. So the only children they could have would be A type blood or B type blood. So for parents 3, they could probably be the parents to baby 1. So we're going to put 3 here. Okay? So that's the first thing that we're going to do. All right, I have to erase the screen to give us some more room. So let's take a look at baby 3. We know that baby 3, they can only have the AB combination. Whoops. This is not working for me right now, so imagine that's an A. And I don't know why my other I isn't coming up correctly. All right, so this is B. So if I go back and I look, there's no B antigen here, so parents 2 could not be the parents to baby 3. But look at parents 1. One carries the A allele, one carries the B allele. So parents 1 could be the parents to baby 3. Okay, let's take a look at the O allele. All right, so we know our O allele has those 2 recessive I's, and we can already eliminate parents 3 because we did the Punnett square over here and we saw they could not produce an O allele child. But could these parents both carry the O allele? Yes, they could. So they could be the parents of baby 2. Could both of these parents carry the O allele? They could. So parents 2 could be the parents of baby 2 as well. The only parents that could be the parents of baby 1 would be 3, or could they? Could these parents produce a baby? They sure could if both were carrying the O allele. So parents 1 could also be the parents to baby 1 as well. So who are the possible parents of baby 2? We answered 1 and 2. Who are the possible, I think that's 2, or is that 3? Now that I can't see this, I don't want to have to erase it. I think that's baby 1, I'm sorry. Who are the possible parents of baby 1? Both 3 and 1 could be the parents of baby 1. Who are the parents of baby 2? 1 and 2 could be the parents of baby 2. And who could not have been the parents of baby 2? Well, parents 3. All right, does that help you understand a little bit more? I hope so. Okay. I'm going to erase if it lets me.